Okay, so I have this interesting problem on the board. We have xy plus 9x plus 3y equals 272, and we need to solve for x and y, which are integers greater than 0, where x is greater than or equal to y. So to start with, what I want to try to do is I want to try to factor the left side, and that's really the whole point of this problem, is trying to factor a expression that maybe we're not that used to factoring with two variables. So to start, what I'm going to do is I'm going to take the first two terms and I'm going to factor out an x so that we have x times y plus 9. And then with the next piece, we have this 3y. I'm just going to take out the 3 and then I'm going to force this to look the same as this. But what we did by doing that is we actually added a 27, so I'm just going to add that 27 back on the other side so that we can stay balanced, so that we don't change the equation. And this number will be, when we add these together, will be 299. Now this is actually factoring by grouping. We have a common term, y plus 9, so we can separate that out. And then we have an x plus 3. And so now we have a nice factorization, and this will equal 299. Now for 299, I'm just going to tell you what the prime factorization of that is. It's going to be 23 times 13. And so because this is, we said that originally xy is integers, there's only going to be a few possibilities because these numbers are prime, so we can't factor this too many different ways. There's actually 4 different ways. We could, because we only have 2 terms here on the left, so it could be 299 times 1 to get 299, or 1 times 299, 23 times 13, and 13 times 23. So those are all the possibilities. Now we'll see pretty quickly that if most of these aren't going to work though. So what we'll do is we'll go case by case. We'll start with this one instead. When if this term is 1 and this term is 299, then x is going to be -2 and y is going to be 290. But that's not going to work because we said that x has to be greater than y, and then also that it has to be greater than 0. So that is clearly not a solution. Then the next one, we have when this term is 23, we're going to have x is 20, and then when this term is 13, we're going to have 4. So that looks valid because x is greater than y, and both terms are greater than 0. So that is a solution. But let's see if there's any other solutions. Then if this term's 13, then that means x is 10 and y is 14. But that doesn't work because it fails this condition that x is going to be greater than y, so that's not a solution. And then last, for 299, x is 296. But for this term to be 1, y has to be -8. X is greater than y, but y needs to be greater than 0, and it's not. So therefore, our only solution is this one, x equals 20 and y equals 4.